scientists, you just watched a video, a Dr. Banach's video on gravity. Did you figure out why they call him Dr. Banach's? Because his eyes are binoculars. Now we're going to watch this book, What Holds Us to Earth. So it's some more information on gravity. We have our table of contents that tells us what the chapters are. And this is on Epic Books too. So if you want to go back and reread it, you can find it on Epic Books. Here we go. Something is different. Look at this picture. Does something look out of place? You're right. The woman is floating in the air. How is that possible? The woman is an astronaut in outer space. People float in space because there's not much gravity. And our caption there says, outer space has only a little bit of gravity. Astronauts call it microgravity. Micro means very little. It's a prefix. A strong pull. Gravity is a force. It pulls things toward the center of the earth. A force is a push or pull. The ball falls to the ground when you drop it because of gravity's pull towards the center of the earth. You cannot see gravity, but you can see how it affects things. It pulls on waterfalls. It pulls on falling leaves. It pulls on a boy down a slide. That's why we go down, because of gravity. Oops. Watch out! A plate will fall to the floor if you drop it, which we know. Gravity makes objects fall until something stops them. So it'll keep falling until something stops it. The hard floor will stop a dropped plate from falling, and gravity will keep the plate on the floor. Without gravity, the pieces of this broken plate would float away. So without gravity, everything would just float away. Hey, batter, batter, swing! This batter hits the ball hard. The force of her bat is stronger than gravity. The ball soars into the air. A thrown baseball would fall to the ground if a force from a bat didn't make it soar. So if you drop it, it's just going to fall to the ground. The bat is making it soar. But wait. The force from the bat is weakening. Gravity is pulling the ball down. A player waits to catch it. When a player catches a ball, she stops gravity from pulling the ball down to the earth. So this is the center of gravity. Gravity helps things balance. Everything has a center of gravity. A center of gravity is its balancing point. We all balance. This model seesaw's center of gravity is at the center of the board right here. The seesaw can balance if it's supported at the center. Gravity pulls equally on an object's center of gravity. That's why objects can stay balanced if they're supported at this point. Have you ever tried to do that before? Try to do it now with your pencil. See if you can find the center of gravity. Kind of. Nope, that's not the center, right? Because it's falling off my face. This pencil can stay balanced because it's supported at its center of gravity. Gravity in space. Gravity's pull helps us live on Earth. It keeps water from floating away, thank goodness, and it lets things stay in place. Many people's drinking water comes from lakes and streams. If we didn't have gravity, this water would just float away. Other objects in space also have gravity. Objects with more mass have gravity. And mass is the amount of matter in an object. How much stuff is in an object. The sun has a lot of mass. The sun's gravity is very strong, which we learned about that a few weeks ago. The moon has little mass. Its gravity is weak. Astronauts bounce and float when they walk on the moon. Have you ever seen the video of the first men in space to kind of bounce and float? Astronaut Edgar Mitchell walked on the moon in 1971. So that would be a great extension activity, is to Google and research the first people who walked on the moon. Maybe there's even a video on YouTube of it. What is weight? How much do you weigh? Never ask a lady how much she weighs, just so you know that. Never ask a lady how much she weighs or how old she is. Your weight is how much gravity pulls on your body. So this person's standing on a scale. This scooter weighs about 180 pounds, which is 82 kilograms. On Earth, you weigh less than this scooter. Gravity pulls on the scooter more. So the gravity is pulling on the scooter more because it weighs more. Imagine you visit the moon with the scooter. That would be fun. Both you and the scooter have the same mass on you as you did on Earth. You didn't lose any parts, so you're still made up of all the same stuff. But on the moon, the scooter weighs about 30 pounds, and you would weigh even less. Since there's less gravity on the moon than Earth, things weigh less. So gravity, your weight, depends on how much gravity there is. So less gravity, you weigh less because it's pulling on you less. Floating through life. Do you remember the astronaut at the beginning of this book? The woman floating on the first page? Astronauts need to learn how to live with little gravity. They need to learn how to hold on to things in space or the things will float away. So if you can tell from the photograph, these astronauts are actually strapped in sleeping bags so they don't float around when they sleep. Otherwise, they'd bump into all the machine and equipment. And they have to eat special food so it doesn't fly around. Everything gets tied up when they're going into space. Astronauts even need to learn how to work upside down because without gravity, there's nothing to hold them down. So they kind of flip around a little bit. Take a look around you. Gravity is everywhere. Can you imagine your life without it? What would life be without gravity? So right now, you would be floating maybe on your ceiling watching our videos. And some of you girls, your hair would be floating in space like that. So it's a good thing we have gravity. Tomorrow, we're going to do more with gravity, and we're going to do a science experiment tomorrow. So have your science experiment page that's attached to the Schoology, or you can write it down on a sheet of paper.